Okay. I think we're all set.
All right.
At the end of 2017, a galaxy 236 million light-years away began a rare and dramatic transformation. It's an event astronomers are still puzzling over, one set off by changes near its central black hole. They first explained this as a tidal disruption event. That's when a star wanders so close to a supermassive black hole that it's torn apart. A new study of observations spanning the entire event suggests a different cause. The trigger may have been a flip in the magnetic field in the disk of material around the black hole. The Sun's magnetic field reverses polarity every 11 years. On longer timescales, even Earth's magnetic field flips. Starting in December 2017, the galaxy began to brighten in visible and ultraviolet light. The source of this brightening appeared to be the disk of material around the supermassive black hole at the galaxy's center. It peaked 3 months later at nearly 100 times its previous brightness. That's when regular monitoring with NASA's SWIFT satellite began. As the visible and UV brightened, X-rays from the galaxy dimmed. By August 2018, the higher energy X-rays had disappeared completely. A few months later, the high-energy X-rays came back, even brighter than before. They returned to normal within a year. These X-rays come from a cloud of super-hot particles near the black hole. It's a feature called the corona, which is formed by the strong magnetic field. The lack of higher-energy X-rays means that this structure was essentially gone. Based on observations from SWIFT, Europe's XMM satellite, and ground-based optical and radio telescopes, here's what may have happened. The visible and UV flare results when the flow of matter into the black hole increases. This may have started when the magnetic field in the disk's outer regions began to flip. The weakened magnetic field can no longer support the corona, which vanishes. The flipped magnetic field gains strength, restoring the X-ray corona, but the inward flow of matter is still high, so this emission is stronger than it was before the flare. Finally, the corona and disk return to their states before the flare, now with a flipped magnetic field. Rapid changes in UV and visible light have only been observed in a few dozen active galaxies like this one. But this is the first time X-rays have been seen to drop out as other wavelengths brighten. These surprising events offer a tantalizing glimpse at the extreme forces at work near an actively feeding supermassive black hole.
Well, hello everyone. This is Scott Roberts from Explore Scientific and the Explore Alliance, and we're here for the 94th How Do You Know program with Dr. Daniel Barth. Daniel, your program today had me kind of worried about this sample return mission, and I guess there's unfortunately some good reasons for us to be
I'm
worried.
concerned.
So, right?
Yes, and
Yes.
that video you just showed had me a little concerned. I couldn't help thinking, what would it be like to be inside of a galaxy that brightens by a factor of 100 from the
Uh,
core out?
it, w- it would you'd be getting a nice suntan, I think. So I don't
Yeah,
know.
I know our atmosphere blocks a lot of UV, but how much would it take to overwhelm our
Probably
atmosphere?
not much. Probably not much.
Probably not, and that's just I look at that kind of event and I'm just like, wow, that's amazing. So yes, and has no doubt viewers are noticing we're not in a regular studio today. Our studio is being renovated, so
Yes.
we're going to be getting that updated, and we're out at a regular desk today. So if you hear and see things that aren't usual in the program, bear with us. So let's go ahead, Scott, and start with our news for the week.
Hmm.
And this one I found really fascinating because I know a number of people in our company use Starlink when we go to remote sites for star parties and events. I know that Explore Scientific has a Starlink system that they use occasionally. Now, the FCC has unanimously approved a framework for what they call supplemental coverage from space. So
Hmm.
now companies can take your cell phone signal and reroute it through a satellite if you go really, we're talking about going out of the coverage area. So I'm
Hmm.
assuming we're talking about places like out in the ocean, uh, in the Sahara, out in the outback, some places in the western US where there's just no cell coverage. And there's some companies like Link Global and AST Space Mobile and Starlink, of course, the Elon Musk company. They're already working on plans. So I'm assuming that in a few years you're going to be able to option a data plan that says worldwide coverage without gaps. And no matter where you go, there'll be a satellite
You're going to
overhead.
be connected, huh?
You're going to be connected. So it's an increasingly connected world.
So if I'm flying on a plane, could I still get like a satellite connection on a satellite phone? I remember seeing movies, action
I don't see
movies
why
where they
not.
called with a satellite phone.
Right. I don't see why you couldn't. I don't see why you couldn't. In this case, I would think that would be routed through some kind of a server on the airplane
Mm-hmm.
because they'd have to uplink to the satellite instead of using ground technology. But I don't see any reason why you could not do that. Why you couldn't have worldwide direct dial cell phone
So if
service
you're on a plane
virtually
with
anywhere.
200 people on it and they're all like on the phone at the same time,
Yeah, well,
that's got to be,
maybe you pay to be higher on the queue. Maybe that's
maybe.
part of your first class ticket. You're guaranteed access. And if you
Oh, that
have
would be
economy,
nice. Hmm.
you kind of get access, maybe, maybe not.
Maybe, maybe
I don't
not.
know. I don't
Hmm.
know, Scott. It's kind of funny. Other things in the news, we are looking at dark matter again. The dark matter chase continues. And just to update you, no one's found any yet. But they're now looking at the idea that Vera Rubin said, gee, there must be a shell of dark matter. That's what makes galaxies rotate in a non-Newtonian way.
Hmm.
And the theorists are now working and saying, well, if dark matter is really real, it has to be modifying spiral arms in galaxies real time. And if it's modifying galaxies in real time, then it should adhere to certain theoretical models. So what they're now planning to do, they're planning to use the Vera Rubin Observatory, which is located in Chile. And they're going to look at streamers of stars and gas being stripped from dwarf galaxies orbiting spirals. Like, of course, the Magellanic Clouds are being stripped right now by the Milky Way's much greater mass. And these streamers, if they're there, they should behave in a way that's consistent, if dark matter exists, with the current theory on dark matter. And they're hoping that even if it's not quite exact, that this will constrain. One of the things we talk about constraining, you can do an experiment which says, well, I didn't find the monster under the bed, but that means it can only be in the closet or behind the door, right? So every time we look someplace and we don't find the monster, then we can cross that place off our list and say, we need to go looking somewhere else. 25, 30 years we've been looking, and we continue to find no monsters under the bed. So I'm kind of a famous skeptic on dark matter, Scott. I think dark matter is going to be like phlogiston and the luminiferous ether. I think we're eventually going to find out that it's our theory of gravity which needs to be modified, rather than we have to create this whole new mysterious class of material that makes up so much of the universe. That's the thing that gets me. If it's supposed to be an enormously high, our baryonic matter that you and I are made of, like 4% of the universe, and dark matter is supposed to be 60%. Wow, that's an awful lot of stuff to be hiding this well, this long. So we'll see. Ultimately, my opinion and yours don't matter. Data matters. And I look back to the heliocentric and geocentric models of the universe. Is the solar system Earth-centered or sun-centered? Those two models existed, as you know, Scott, for over 2,000 years, where people were teaching and using both at their convenience, because neither one had been falsified. And it took Galileo, with new technology, the astronomical telescope, and a series of observations, and he was able to finally prove the Earth can't be in the center. So we're waiting for that critical experiment that will say, aha, I have proven that the dark matter theory is not possible, or eventually it'd be great if we got proof saying, oh, somebody said, look, I found something. Here's where I found it. Here's what kind of collider I needed to get it to appear, kind of like the Higgs boson. We need a very powerful collider to make it appear in our detectors. That'd be awesome, because that would say we've been on the right track for 50 years. On the other hand, every astrophysicist gets this little smile on his face when we get things because it's these cracks. Gee, we can't find an answer. This nature doesn't seem to be supporting our wonderful theory. It's these discrepancies that lead us to new discoveries.
These pesky other
the pesky things that won't go away. Look.
So talking about peskiness, what about Mond and
yes,
is it
Dr. Milgram's work?
Some more ground? Is the jury still out? I mean,
the jury is still out. And I will admit to you and to our audience that I do not have the math skill set to look at Dr. Milgram's work and say, yay or nay.
Or nay. And what does MOND
I'm sorry.
stand for anyways?
Dr. Milgram is one of those people. Yeah. What was the famous quote about Einstein? He's written the book Only 12 People in the World Can Read and Understand. And I think Dr. Milgram's work is in a similar. I think 12 might be a little low, but no, the jury is still out. And Milgram himself hopes that within 20 years, he says, within my lifetime, I hope to see some kind of experimental evidence. So, you don't always, as a scientist, you're not always that lucky. Dr. Gilbert Levin, who said he detected microbial life on Mars in '76, right, with the Viking lander. I got good results. Right. And that jury is still out almost 50 years later. It's be the 50th anniversary. 2 years from now, 2026 will be the 50th anniversary of Viking. So, and Dr. Levin passed during the COVID pandemic, and I don't know if it was COVID or not, but yeah, he did not live to find out. Anyway, so other interesting things coming up. The FCC is now going to require re-entry licenses. So if you want to send something that goes up, must come down, but it
Right.
must get a license somewhere in between those two processes.
So
And
these SpaceX boosters that come and land will
that's
now
right.
need a,
That's
they're
right.
gonna need a hall
And
pass to get back in, huh?
I'm going to need a hall pass. And one of the things is, of course, we've got an awful lot of space junk up right now. Got a tremendous amount.
Oh, yeah, we
And
need to clean that up.
one of the things behind this is not just the, oh, tax the landing spacecraft. It's not about that. They are looking towards moving toward a system where you will have to provide some kind of means to deorbit your equipment before you get a permit to launch it.
Hmm.
You can't just, drive your car until it runs out of gas and leave it in the middle of the road, so to speak, which is basically what we've been doing with spacecraft for 50 years. We've been launching them and then forgetting about them.
Well, could it be that they're looking for a revenue stream to figure out how to get, you know, giant orbiting dump trucks up there to go and gather the space junk and bring it down?
There have been a lot of discussions about the possibility of an orbiting spacecraft with grappler arms and
Yeah.
different technologies. They've talked about sending out essentially a streamer. You come up to some debris like a satellite and you launch a streamer which has an adhesive component, and it hits and it sticks and it unfurls, and now your satellite is trailing a couple hundred meters of mylar ribbon, which create drag and
Okay.
pull your satellite out of orbit. There have been
I see.
lots of ideas, but as you might imagine, testing this technology is not cheap. And the real nightmare scenario is some kind of a war in orbit where people are sending up anti-orbital satellite weapons and they're blasting satellites and creating clouds of debris.
Oh,
Um,
great.
yeah, that would be the nightmare scenario.
Yeah.
The other one, and you've got my show notes there, and I know you're of my age group. Do you remember George Pal's Destination Moon? I know you didn't. We didn't see it live in the theater, but
No,
I
it's
saw
like
it
a
on TV.
50s
50s, yes.
B sci-fi movie, right?
Written by Harlan Ellison. It was
Okay.
very good for its time, but the astronauts had brightly color-coded spacesuits with bubble helmets. And if
Ooh.
you look at Boeing's new spacesuit that they've designed, the Boeing Blue,
Yeah.
it's basically a flexible spacesuit with looks like army boots on the bottom and a bubble helmet on top, and it looks very, very much like the next year's model of George Pal's 1950 spacesuit from Destination Moon. The really nice thing, this new suit weighs 20 pounds. The old Apollo era suits, 180 pounds.
Wow.
Yeah. Here, let's put on a jacket that weighs as much as you do.
Right. Well, if you're in space,
You're in space, but you've got mass and inertia to move around too.
I see.
And, I always wondered why low gravity made the astronauts hop like that. I'm thinking, oh, if I was wearing essentially armor plating that weighed as much as I did, yeah, I can see why maybe why they moved that way. Anyway, let's go ahead and talk about our main topic for today, which is the Mars sample return mission. And this mission is in trouble. As Scott, basically, we haven't gone beyond low Earth orbit with people since 1972. And when we want to do things in this country and on this planet, we can get them done. Took
Sure.
us 7 years to go from first man on the moon to first lander on Mars. 7 years. And that's a tremendous leap in technology.
Sure.
And basically, we've got this. If you have paid attention to people who talk about boots on the ground on Mars, it's been kind of like an old song that won't die. Landing on Mars is 30 years away, right? They've been saying it since the 70s. It'll be around 2000. It'll be 2010, 2020. And here we are in 2024, and they're still
Right.
saying 30 years.
So we got 6 more years left, and then we need to get something up there.
I think so. And we've
Someone up there.
That's right. And of course, you get the group that says, well, why do we need samples from Mars? Part of the reason is, apart from general scientific knowledge and interest, part of it is this idea that we need experiments to test and come out and figure out things that remain unresolved. We have this big, and it's been kind of swept under the rug, but we have this big problem. Gilbert Levin in 1976, he met every single criteria for saying, yes, I've discovered bacterial life on Mars. All the criteria that were set up by the worldwide scientific community in advance, he met. He ticked all those boxes. They still said, we don't like the result, partially and mainly perhaps because the other three experiments, which weren't as sensitive, said no. But you've still got this. One guy says the Earth in the middle of everything. The other guy says the sun's in the middle of everything. They can't both be true. How do we decide? And I've been saying quite for decades, we need to have people on the ground. If you had people on the ground on Mars, this question of is there bacteria in the soil would be a matter of an afternoon's work, right? You and I could do it with an explorer, with a National Geographic microscope.
Yep.
And a plastic pail and shovel from the beach.
That's
and
right.
a couple of slides. And if there were bacteria there, I'm exaggerating a bit, but seriously, a trained astronaut with a microscope could certainly detect
Sure.
these bacteria very, very
Sure.
quickly. And remote sensing science is hard. Remote biology is ridiculously hard. And so really the primary answer has been, let's bring some samples back. And we do have rocks from Mars. We do. I have one in my own meteorite collection. It's a small piece of Martian breccia, which was blasted off Mars, I don't know how many millions of years ago, made its way, but coming through the atmosphere, being exposed to Earth's magnetic field and the fiery heat of reentry, not any really good evidence in my little rock from Mars. We need more pristine rocks from Mars. And there were lots of reasons why people said, oh, life on Mars cannot be true. But interestingly, over the past 48 years since the Viking experiments, virtually all of the prima facie reasons that their life cannot be on Mars have kind of gone away. The idea that there's no available water, that the temperatures are too high, that there's too much radiation flux. All these things, we keep finding extremophiles on Earth that live in extraordinary conditions. And the big one was always water. The idea that Mars was totally dry and so could have no life. That we know is absolutely false now. And Steve Squires, back in when Spirit and Opportunity were new, announced Mars used to be, millions of years ago, warm, wet, and habitable. That doesn't mean inhabited. I always clarify that point whenever I mention that. But yeah, there's no reason Mars couldn't have had life. And did it all go extinct? Again, my counterpoint to this has always been sterilizing something is atrociously difficult. I don't care if you're talking surgical instruments for an appendectomy or a clean room for someone with a terrible disease, or my God, sterilizing a planet would be.
Try to get rid of black mold out of your house. I mean, it's
Yeah, exactly. Thank you. Exactly.
very difficult.
The energy budget for sterilizing a planet. Well, yes, a sun can do it when it goes red giant. That's got plenty of energy budget. But you can't sterilize things with cold. Doesn't work. Doesn't work. Matter of fact, you preserve bacteria with cold. We freeze-dry bacteria for preservation all the time. So we need to get a sample collection. And Curiosity has been collecting samples. And it was designed this way. It has a drill, it has a rock collector, and it can put things in samples. And the sample tube design, Scott, is just amazing bit of kit. It's double walled, it's protected, it's insulated. They want no contamination at all in this before it gets there. And these samples when they get back to Earth, much like the samples from OSIRIS-REx, those were in curated lab conditions, basically within an hour and a half of hitting the Earth's atmosphere.
Hmm.
They're, they had people literally on site and rushing to the return to space vehicle, the return vehicle, and they're going to do the same things here. The problem is, see, it's a government project.
Hmm.
And so the costs have tend to run away. They also designed the front end. Let's make a robot to go collect the samples before they ever designed a robot to go get them.
Mhm.
And so I've got this great idea. There's this gold mine. Well, how are you going to get the gold back? Well, we'll figure it out once we get there.
That's right.
Infrastructure is hard,
Right.
you know.
Well,
Let's
maybe someone like Alan Stern, could, he's pretty famous for getting things done under budget,
oh yes,
on time,
oh yes,
and, New Horizons spacecraft is still active, still has
yes
fuel,
it is.
still is a ongoing mission,
I think there are people who could get this done, but they would have
Yeah.
to have probably a freer hand than they do.
Yeah, that's probably true. It'd be
Uh,
sad if it all boils down to politics,
oh, please let it be anything but that.
anything.
I am willing
I
to
agree.
say, you know what? This was too hard for us. We don't have the technology yet. We tried, we failed. We're going to leave this for future generations. We do that all the time with archaeology and space samples anyway. Most of the stuff from Apollo is still waiting for future generations. We've opened only a tiny fraction of the stuff.
Sure, sure. John Ray, who's watching right now on Facebook, says, we space age humans are often described as coming out of our Earth cradle.
Yes.
If we reach out too far from time to time and miss the grasp, we usually do better next time.
Yes, John, you're exactly right. And I see no shame in this. To try and fail honorably, I see no shame in this. But to let our
Sure.
politics destroy our science, this is akin to, Hitler yelling nasty insults about that Jewish man Einstein and
Yeah.
saying it can't be true because I don't like him.
Yeah, I don't like him.
Yeah, God,
Yeah.
let it not be politics. If the mission fails and it doesn't succeed in my lifetime, I'm content, but let it not be politics.
Yeah.
Let's just have maybe we're trying to reach too far and our reach exceeded our grasp.
Mhm.
The other problem right now, the price tag for collecting the samples, the Mars sample return, right now, price tag is 11 billion, and the original budget estimate was 2 to 3 billion. So you figure, oh, they're around 4 times their original estimate. Is that not, when you hear an estimate for, I don't know, we're going to build a bridge, don't you usually look at what the government says it'll cost X and in your head kind of multiply by 3 or 4 anyway? I do.
Right.
I do.
Well, if it's a government project, it does, there's probably many examples where you could show how the government inflated costs of a project unnecessarily because everybody's got their hand out, right? So,
Correct. Oh, if we make my special thing part of your project, I can get money through your project to do my pet
to
thing.
fund my whatever, yeah.
Yep. And that happens all the time.
Mhm.
And you say, well, what about just giving the astronauts a map and saying, hey, while you're up there, just go collect these things and bring them back. But they estimate the cost of a manned landing at about 50 times the 11 billion Mars sample return price.
50 times.
That's the estimate. I don't know that that's true. I look at the Apollo program as my example of how this can and should work. There was a huge amount of pressure to get the end goal. And we were working on, it was very famous that the LEM was the last thing to be finished and designed and tested before the astronauts went up, but it was one of the first things they started working on. Some parts of the project take longer than others. It's just true that they do.
Well,
Um,
they could give this to Elon Musk.
they could,
You know,
and that might be a good decision.
SpaceX is doing things.
Yeah,
I mean,
contract
I'm
with
looking
SpaceX.
at an article right now, 10 times less. So if it was going to be 11 billion, then if it's 10 times less, that's 1.1 billion. I say give the rest of the money that you thought it was going to be to Elon Musk and say, get the job done, okay? Like
I think you're right.
this year, okay?
I think you're
And
right. I think by 2030 we would have samples, and if we did that today, I
yeah,
think by New Year's Eve 2030 we'd have samples in our
yeah,
hands.
that'd be a nice Christmas story. So,
It would be. It would be. And you figure, okay, well, we only have launches every 2 years, and it takes 1 2-year cycle to get out and get back. But if we started now, it's 2024. That gives you 3 2-year cycles between now and the end of the decade. I think
yeah,
Elon could do it. He has my vote.
he's got my vote too. John Ray is asking a question. He says, do we really have a time limit for retrieving the Martian samples? And if so, how long?
I don't think so. I don't think they have a sell by
I mean,
date
they're
on
not going to
it.
spoil, right? I mean,
No, they're not. And they're essentially, although they've been dug out of the soil, they've been put in a tube and then just set back on the ground.
like hermetically sealed, maybe,
Yeah, they've been
right?
hermetically sealed, and essentially, I've got my insulated tumbler, and it's just about the same thing. Uh, I'm sure it costs a little more, but they have these tubes, and
Unless
they're
it's a Yeti container,
right.
so
That's
they're
this
about
is
the same
my
price
this
as
is
the
my Yeti
NASA.
this is my
Yeah,
Yeti drink cup, and I don't think Yeti made the collection sample cases for NASA. They probably could have done a very nice job. Thank you very
I'm
much,
sure they could have.
but they they're essentially sitting in the same environment, temperature, humidity, radiation, everything is the same. They might be a
Okay,
little more shielded from radiation, and radiation always decays. It never enhances. So I think those samples will be good for decades and decades to come. God willing, we don't wait that long to collect them, but I don't think
yeah,
there'll be anything wrong with them.
right.
Um, and right now, you think of what the Mars sample return has to do. It has to come down, it has to land. Well, the sky crane that NASA has used for Curiosity and uh, the other rovers, they can't use that for an MMR landing because they have to land softly, and they can't use the MMR, so they have to design a new lander. Once they land, they have to deploy the robot. The robot has to have an accurate enough GPS system that it can drive autonomously to the collection sites. Then it has to be able to spot them. One can imagine they may be covered with dust, and they may be soil drifted over them from windstorms. If we get one of these big global dust storms between now and when the sample return mission lands,
Yeah,
that's going to make finding them challenging. And I don't think these things have Apple AirTags. Uh, you know,
yeah.
I don't
Even
really
if they
think
did,
they
they
have
wouldn't
any
have the
kind of.
batteries that could survive that long. So,
I wonder if they have like a passive RF tag. Like the
that would have
chip
been
that they put
smart.
in pets.
Little
Because those are
RFID
completely passive,
tag
right?
in there.
Yeah, and then it'll beep if you get within a meter or two. I'm
Yep.
just I have no idea.
Or
I
some
don't
sort of
know
metal
anybody who.
detector, it's going around and
Yeah, but there's that challenge. Once it finds all these samples, and there'll be, I think there was supposed to be, what was it, 25 of them or something close to that? It's supposed to be
hmm,
quite a bit. And they're talking about possibly to cut the cost. Oh, well, let's decide which ones are more and less interesting, but it's
how
hard to tell.
how would they know? I mean,
That's the thing. It's a guess. You know
hmm,
what I know, Scott. If you're going and hunting fossils, you could pick up a rock and say, gee, I wonder if there's a fossil inside. And you or I might be guessing. A geologist might have a good guess,
yeah,
but no, you got to crack that rock before you find out if it's got any joy in it. And
Right.
if you've talked to anybody who's searched for fossils, I've done, you break a lot of rocks without finding anything. And sometimes the most unassuming looking things contain the greatest treasures of all. So,
Hmm.
um, and once they land and collect the samples, then they've got to upload them into a vehicle that's going to return to space. So, unlike the LEM, which was essentially a lander and an ascent rocket in one package, right?
Yeah.
It landed, then the top half. For those of you younger viewers, go look at some video of the Apollo 11 return to the Earth because they left a video camera on the moon. They got video of this, the ascent module blasting off. The rover isn't going to be like this because the LEM was stationary, it didn't go anywhere. This new rover, this new lander is going to have to land, deploy a rover. The rover's going to go collect stuff, come back, and does it come back to the same base station, or do they land a second vehicle? That's not been decided.
Hmm.
So they might be landing a separate ascent vehicle, and then the rover collects everything and then drives there, and basically offloads its canister, robotically, of course, into the ascent vehicle, and then the rover would back off. One would assume the ascent vehicle would take off, but that's not the end of the challenges. This thing has to do an orbital rendezvous and dock
Hmm.
from Mars completely autonomously. Now, we've been doing space docking since about 1967, but we've always had a pilot in both ships, and they had a camera, and they've been looking out going, okay, click, good, we've got it locked. All the Apollo missions, all the various Soyuz missions, all these missions that have done space docking, they've all done it the same way with people on board. Now they've got to do it autonomously on another planet 100 million miles plus away.
Right.
Once that ascent vehicle docks, then there's one more transfer of all the goodies into the return to Earth vehicle. The ascent vehicle, they don't want to use the power or the fuel to bring that thing back. They're going to jettison that. And then the return to Earth vehicle will fly back to Earth. And probably like OSIRIS-REx, there will be a jettisoned package. The lander, the Earth landing package will be very small and will just be jettisoned. That's now I'm not on the design team, friends. I'm not talking. They're not asking yours truly. Maybe they should, but they're not.
Maybe they should.
Maybe they should. But this is it's the most complex space mission ever designed, the Mars sample return.
Hmm.
And it's more complex than the Sky Crane by a number of times would be my estimation. Just because of think about all the different this is my sample container, right? Think about all the different things this has to go through. Curiosity drops it. It's on Mars, and now it has to be collected. It has to be driven over somewhere. It has to be loaded. It has to go into an ascent vehicle. It has to go up into orbit. Once into orbit, it has to be transferred again, has to fly back to Earth, and then it has to detach. And that capsule and this part stays in space. There's a lot of moving parts here, Scott, figuratively and literally.
Hmm.
So, like the original Apollo mission, we do not choose to do these things because they are easy. We choose to do them because they are hard. And Kennedy said our job was to send a man to the moon and return him safely by the end of the decade, as he said in his lovely
and we did.
His lovely Boston accent, and we did. But that was an all hands on deck. The entire nation's essentially industrial complex was basically mobilized for that effort. I think we're going to have something similar, either that or, as you said, we're going to have to stop sucking on the government teat, so to speak, and transfer our space exploration to private companies. I have long believed that we will colonize the moon. I have also adamantly believed that governments will not do it. Private companies and private citizens will do it.
Mm-hmm.
The government didn't settle the West in the United States The government didn't.
No.
The last time I think government exploration and big settlement was a real success was the Spanish with sending Columbus over to the Americas. Uh, Government colonization is just fraught with horror stories and missteps and good Lord.
And
Australia.
cost overruns.
Can I say one word? Australia. Okay. Not that, and you don't need a good beginning to have a good ending. Hey there, Oz. Aussies, a lot of you are friends of mine. You don't have to have a good beginning to have a good ending. That's just, I learned that a long time ago teaching. So we're going to get there. But this is a serious challenge, Scott. And we have just run smack against the big wall, realizing how much we need to do.
So if we compare this $11 billion price tag to go get this stuff, and we compare that against, let's say, the Hubble Space Telescope, what do we have into, I don't know if you have that number, but the cost
I
today,
do right off my.
cost of HST,
I was wondering what the cost of Apollo would be in modern dollars.
well, we're still running Hubble.
Yeah,
So the Hubble mission cost was approximately 16 billion adjusted for inflation to 2021 dollars since its official start in 1977. Okay.
There
Now
you
we
go.
have a rover, it's still working. Okay.
right.
We start to amortize this stuff out.
Oh yeah, I
and
agree. I agree entirely.
I read a article where they, divided up the cost of the Hubble Space Telescope to every man, woman, and child that lives in the United States. And basically, for the cost of an evening at the movies,
Right.
okay,
Right.
right? We
Right.
have a Hubble Space Telescope.
Correct.
And so I think that going and retrieving actual material from, Mars
Yes.
is the $11 billion price tag is well worth it,
I think so.
I think it
think
is. But
absolutely
do I
true.
think it can be done for a lot less money? Absolutely, so,
But even if we had to spend the whole, buy it for retail price, so to speak, right?
yeah, yeah,
I think it would be a bargain. Hubble has returned, it's changed the entire consciousness of our civilization.
that's right. And
And
retrieving this
this mission
material would
has,
do the same. It would do the same. Just,
yes,
I mean, even if it was
yes,
unremarkable, even if it was just like the materials that we find here on
even if it was
Earth,
just like dirt from the parking lot,
that would be remarkable
that
just to
would be,
know that,
it would be. And I
So,
think it's
and
just
comforting
something,
somehow.
it's something we need to pursue.
Yeah,
As a culture, as a country, as a spacefaring nation, it's something we need to not let this go.
right.
Uh, ev- Throughout history, the history of human beings, when human beings are active and expanding and dynamic, their civilizations flourish and they're glorious, and they produce art and culture that is still part of our heritage, thousands of years later. And we as a spacefaring nation, same thing. We need to be outward bound. We need to be focused on the next step,
Right.
not on worrying about the footprint left behind from the last one. And obviously, you can't take either analogy to extremes because you can't just, destroy your environment for the sake of exploration, nor can you say for the sake of preserving the environment, everybody freeze and we're not going to do anything now. Neither stagnation nor unlimited growth is a wise path.
And
But,
I'll offer one last piece of kind of perspective.
sure,
$11 billion sounds like a lot of money, right?
does.
Guess what Elon spent on Twitter?
Oh, that was 44 billion, wasn't it?
$44 billion.
Yeah, yeah. We could have
So if
put
we
people
gamble,
on
I mean,
Mars.
just right now, if Elon's listening, okay,
That's
all
right.
right, if he can get NASA to put up a wager, okay, that, you know, bet him $1 billion or whatever, okay, that he can't get it, okay?
He
That
just
he
has to come
can't.
back with one tube. He can come back with one sample tube.
Yeah, at least one, that's right. So
Because one would be a whole
I
lot.
think Elon could do it.
You think about Osiris-Rex. They were hoping for between 5 and 60 grams of material from asteroid Bennu. They
Right,
came back with a couple of kilos, right?
right.
And the first distributions were milligrams in size. They were a few thousandths of a gram. And we collected like 3,000, 3,500 grams of material. And we were sending people 5 thousandths of a gram, 7 thousandths of a gram. So yeah, one tube.
One tube,
And
you divide it
there
up,
is
you sell it, okay,
if
to
there is bacterial
countries
life
to
in the soil
research.
of Mars, and
Yeah,
this is an if, I am certain that it is effectively ubiquitous across the surface of the planet. That's the way bacteria work. If your egg salad is
it's not
spoiled,
just gonna be like in one
there's
little
not going to
area,
be a
right?
corner of it with that's not spoiled. It's the whole thing, right? So if you got bacteria in the soil on Mars, I'm sure one sample container, one, would tell us that.
Hmm,
So
Interesting, interesting. So if any of our listeners knows Elon personally,
that's right. I would like an autograph, and I'll
yeah,
take
I
it.
just want a little
We
bit
can
of
go to
that
lunch.
Martian
My
soil.
treat. Take a billionaire to lunch. I would love to take a billionaire to lunch. I
Sure,
don't care who it was. And
sure.
just to be able to talk to that person and chat and pick their brain for a while, I think that would be
Well,
loads of
I
fun.
think for Elon in particular, that he would like to have this tube and say that he got the whole thing for, I don't know, $2-3 billion. Okay. I know
Yes,
he could sell the material to other countries. So being that the material, let's ask this question. If the material is stuffed inside of NASA tubes, okay,
right.
and they're just left up there, but somebody else collects them, okay, uh, is it
I
finders
think if you
keepers or
abandon a car jack on the side of the road and somebody comes along and picks it up and tosses it in the back of their pickup truck, you lost a jack.
I guarantee you if I leave my car abandoned on the side of the road, somebody's going to pick it up, right?
Yes,
And I'll
NASA is
have to pay a
relying.
hefty fine to get it,
They're
and
relying on the fact that they've abandoned very valuable things in very remote places. And all the history of treasure hunting of ever says that that's not a great security strategy. It's just not.
oh, anyhow, well, that's right. John Ray says salvage rights.
That's right.
That's
Salvage
right.
right.
I don't know what salvage rights are, but I think it's finders keepers.
I agree. I think you and John Ray are absolutely correct. And just want to let our audience know as we're wrapping up today, we will not be on next Monday because
Okay.
yours truly is moving.
Oh,
So
yes.
I will be doing the sad heave ho, and loading boxes on trucks and getting settled in my new home.
Oh, yeah.
So that will be an action-packed adventure, and then we'll be back the week after with episode 95,
95.
and we're going to continue. As you know, I write the shows are kind of organic, but one of the things we're definitely going to put in on our next show, number 95, is manganese oxide on Mars.
Hmm.
They have recently found way too much manganese oxide. And guess how we get manganese oxide on Earth?
How?
Bacteria interact with manganese and oxygen in the air and
Oh,
oxidize the
wow.
manganese, and they use it essentially as an electron transport energy source.
Interesting.
And yeah, and so if there's all this manganese oxide in Gale Crater, where did they get the oxygen? How did they get it reduced into oxide form? So
Hmm.
that'll be something we'll talk about next time.
Okay. All right. That sounds good. I do want to make an announcement that we will not have Global Star Party tomorrow. We are pausing that until June 18th. Um, but it will be our 151st program, and so it has to do with Daniel, you and I talked about the
We did.
theme for the next Star Party. So it does have to do with a view, but an ever deeper view, okay? Because we have just, Jay West has discovered yet another even more distant galaxy that I think we're now under 300 million years. We're looking at an
The
object
Big
300
Bang.
million years after the supposed Big Bang event. So the look back time is getting crazy at this point.
It
And
is.
but I something, I think just kind of, I thought, well, okay, maybe Jay West will get to the point, where they see back as far as they can. I think they have their, uh, the advanced deep sky or deep uh, exploration, the
Aren't
JADE
they doing the
project.
Jades survey?
Yeah, the JADE survey, and they've identified 600 some odd objects. Maybe it's
Right.
more than that,
Yeah,
or
with
it's
a
600
Z number of
anything.
like 14.
So, but we're looking back further and further back, and I think that it encourages us to build an even bigger space telescope,
It
so we
does.
can try to look back even further. And I think if we do build bigger, we'll find more stuff.
Of
So,
course.
yeah,
Of course. That was one of Galileo's original questions when he built the first true astronomical telescope. Will I
okay,
just see things closer? Because he knew if he looked out on on the landscape, he would see things closer up. But he asked the question, will I see things closer, or is there more that I cannot see?
yeah.
And that
And we know
was,
what
you
the
think
answer to
about
that
it,
question is.
that was absolutely an unknown. Is
Yeah,
there more out there than we can detect with just our eye? And of course, the answer is yes.
a lot more,
You know,
a lot more.
oh my God, it's full of stars.
Yeah,
You know, think
and
of Roger C.
microbes.
Clark, Arthur C. Clarke. Yeah. So there we go.
All right.
All right, Scott.
Daniel, thank you so much,
Yes,
and
indeed. Thank you.
we'll
It's good to
catch
be
up to you
back.
on the next Global Star Party, maybe if you're attending, and then
I will.
seeing you on the next How Do You Know?
Yeah, by the time you're ready to do the next Global Star Party, I should be in my new home and have my new studio set up. So I'm
Beautiful.
planning on
Okay.
seeing you. Okay.
All right.
Bye, everybody, and thanks for joining
Yeah.
us.
Thanks for watching, everybody out there. So.
And this is David Levy, that's me, and I am holding the original Discovery films of our most important comet, Comet Shoemaker-Levy 9. These films were taken on the 23rd of March, 1993. Carolyn discovered the comet on these films 2 days later. And on, about 16 months after that, all of the fragments of this comet collided with Jupiter, giving humanity its first view of what happens when a comet hits a planet. And one of the exciting things about this is that when comets hit planets, they don't just drop dust. They also drop organic materials, carbon, hydrogen, oxygen, and nitrogen, which eventually turn into proteins, amino acids, RNA, and finally, on one magic day, DNA. Comet impacts are really the first step in the origin of life.